Hello everyone. This is question number 2, February-March 2023 physics paper 6, variant 2. Here you have a question about a student that investigates the cooling of hot water from different initial temperatures. Okay, so be careful here. The student need to investigate the cooling, how the cooling rate or how the rate of cooling affected by the initial temperature, okay? How the initial temperature in different containers or in different liquids or different temperatures will affect the rate of cooling. So here you have a diagram. She uses apparatus that shown like in this figure. You have a thermometer and a clamp and a stand and a beaker. And the first question asks about the student measured the room temperature. At the beginning of the question, he asked to find the room temperature and then record theta R, which is represent the room temperature in the environment, the surrounding environment. Okay, the first room temperature is 21 degrees Celsius. As you can see, this is 21 degree Celsius. This is the room temperature. The question I, describe one precaution that the student takes to ensure that the temperature reading is as accurate as possible. How can we increase or how can we take a precaution while taking the reading? Okay, here be careful. We need to be careful while taking the reading from the thermometer. So you need to take the scale perpendicular to the line of sight. You cannot say avoid the parallax error here, as you always memorize in all this type of question. You just take a look in the mark scheme and be careful. You just can write in this question, take the scale perpendicular to the line of sight. Okay, so to increase the accuracy of your reading. In the experiment A, the student pours a volume of 100 cubic centimeter of hot water into the beaker and records the temperature theta A at time 0 seconds. So be careful. Here, the student start to get a beaker, okay, and he pour 100 cubic centimeter of water, okay, he pour 100 cubic centimeter of water, and he places and record the time at the beginning. The time starts from the beginning, okay, 0. And she record the temperature of the water in the beaker every 30 seconds. So what will be the controlled variable here in this question? We need to measure the temperature every 30 seconds, not in a different intervals of time. يعني ما ينفعش أقيس التمبريتشر مرة 30 second and the next time will be مثلا 90 and بعدين 80 second. No, you just take the reading of the thermometer in equal time intervals. This is the first one. And the other control variable here, you should to take the same volume of water for the liquid. You choose a hot water here. So you should use a water in each time. مش مرة هجيب water, مرة هجيب vinegar, مرة هجيب oil. لا ما ينفعش. You should take the same liquid to get a fair test. Okay. طيب الحاجة التانية إنه you should use the same volume of water. يعني the same volume be used in each time for each time you take the reading. Why? To get a fair test. Okay, in the other experiment, the student repeat the process But in this time, she waits until the initial temperature theta B of the water is the same value of the temperature theta A at 90 seconds. Okay, here you must be careful here because in the question you didn't, there is the initial temperature doesn't given for theta B, but you have information to record the temperature, the initial temperature for the second beaker. يبقى he repeated the experiment, okay, but in this time he wait until the temperature reach the same temperature اللي كانت في experiment A لما كانت temperature عدى عليها 90 seconds. So what we'll do, we will take a look in the table, okay, here at 90 seconds, okay, what was the temperature? The temperature for the experiment A was 85 degrees Celsius. So this is the initial temperature taken in the second experiment. So the initial temperature in the second time, which is theta B, is equal 85 degrees Celsius. Okay, here in the question C, write a conclusion stating how the temperature at T equals 0 affects the rate of cooling of the water. So we need to give a conclusion from the table about our results. Here you have the results of the two experiments here, experiment A and experiment B. Experiment A, we start until the temperature reach the room temperature and record the initial temperature in the beginning, and time will start at the same time from 0 seconds. The initial temperature for the experiment A was 92, while the experiment B, the initial temperature was 85 degrees Celsius. So can you take a look in the table and record, or can you give a conclusion? Yes, I conclude the relation or the pattern here. Does the initial temperature really affect the rate of cooling? Okay, wait a minute here. What the meaning of the rate of cooling? Rate of cooling mean any change for the temperature per the second. So the word rate, that mean any physical quantity, it change per second. So the word rate, that mean the unit you will use is degree second. يعني any physical quantity here in this experiment, we will use the unit degree Celsius per degree second, because we need to make a conclusion about the relation between the temperature and the time. So, and I conclude in this experiment, and as the temperature initially start, as the initial temperature was greater, so of course the difference between 92 and the room temperature will be the greater, okay? Because this is hotter. Which is hotter, 92 or 85? For example, predict something. If you have the room temperature is equal 25, if the room temperature is 20 or 25, for example, let's take an example, it's at 20 degrees Celsius. So what will be the difference? When the difference will be greater? When you start the temperature from 92, the hotter liquid, or the difference between 85 and 20 is greater? Of course, the difference between 92 degree, okay, and minus the difference between the room temperature, which is 20, it's just example, is equal 70, approximately 70 something, okay. So the difference between the room temperature and the initial temperature for the experiment A was greater. So I predict, the greater the initial temperature, of course, the greater rate of cooling. Okay, how can we justify our answer? Okay, if we need to know how can we justify the answer, you can take a look at your table and predict, or you can observe the result, observe the change between the numbers. Okay, when the object or sorry, when the hot liquid at the beginning, the temperature was 92, okay? After 180 seconds, as you can see here in the table, okay? After 180 seconds will be minus 80 is equal 12 degrees Celsius. Okay, so when the temperature was 92 initially, and after 180 seconds, the temperature reached 80 degrees Celsius, which means that the difference is equal 12 degrees Celsius. So the rate of cooling here is 12 degrees Celsius. Okay, but in the second experiment, when we start from 85, we start from 85 for the experiment B. We start from 85, okay, 85 minus 75 after the same time interval after 180. So it was 75. So the difference was 10. So which is greater here? Okay, take a look here. The difference when in the experiment A, okay, in the experiment A, the rate of cooling was 12. But in the experiment B, the difference was 10. So which is greater rate of cooling? So our conclusion is correct because we give the information, complete information to justify the answer. How can we tell that? By compare the result from the table. So the answer will be the greater the initial temperature, the greater the rate of cooling. And the justification for the answer will be when the initial temperature was 92 degrees, the rate of cooling will be 12. And while when the temperature theta B will 85, so the rate of cooling will was 10 degrees Celsius. Sorry, because our PDF, my PDF can write the degree and this thing, and I'm very sorry. Question number D, calculate the average cooling. So here we need to calculate the average cooling rate, and he named this average cooling rate X1. And in the second part of the question, he need to calculate برضو the average cooling rate, and he named this quantity X2. So X1 is equal theta at the beginning, or for this duration as given in this question. بيقول لك احسب the average cooling rate during the second half of the experiment. The second half of the experiment, when we start from 90 seconds until we reach 180 seconds. So the average will be rate of cooling. So because we're asking about the average cooling rate. So as I said before at the beginning of the video, the rate of cooling معناها انه difference in here the difference with the relation between the temperature related to the time. So when the time was 90 until the time reached 180 seconds, and at time 90 until the time reached 180 seconds. So we return back to the table. Okay, the temperature was 85 when the time was 90, and the temperature was 80 when the temperature 180. And simply you can calculate the average by divided over 90. 90 mean here 90 here 180 minus 90. So the X1 will be this number. Okay, be careful here. You will not get the mark if you couldn't know this unit, because this is very important in the exam for the examiner. He should know, you understand or not, how can you relate the physical quantities to each other? Okay, and this is the main importance in paper 6. So, and the question double I here, we have to calculate the same average, but in the different time intervals. Here we have to calculate the cooling rate x2, but in the different time intervals between the time 0 and the time 90 امتى for experiment B. You return back to the table, okay, and look about this table, which is colored with, for example, let's, if I highlighted with blue, okay, take a look, okay, and we need to calculate the time between 0 and 90. Okay, at 0 كانت 85 and at 90 it was 79 as you see in the table. Okay, 85 and 75.5. Okay, so here we have a mistake. We should correct it. 79.5. Okay. The answer will be 0.06, and again, you should take care about the unit, so you get the mark. Triple I, question triple I here, a student suggests in the x1, the average rate x1 is the same as x2. Okay, look, here x1 is equal 0.056 degrees Celsius per second. And we calculate x2 is equal 0.06 degree Celsius per second. So can you suggest the answer? Does this calculation is support our suggestion? Okay, how can we justify our statement? Is it right or wrong? So first of all, and I think فعلا انه 0.056 degree Celsius per degree second per second قصدي is يعني تقريبا قريبة جدا من 0.06. But how can I justify the answer? Okay, I use very simple method which is يعني بجيب the greater number divide the smaller number, so it will be 0.07. يبقى أنا IA divide 0.06, which is the greater number, x2, divide over the smaller number. The smaller number here is 0.056. You will get a number. The number is 1.07. But take the decimal number, okay? You can calculate the limit of experimental accuracy. Experimental error here is accepted عندنا in our alternative to practical paper انك تكون مطلع ال percentage smaller than 10%. So the answer within the limit of experimental accuracy. So my justification is correct in this question. يبقى أنا I see فعلا إنه ال two reading اللي طلعتهم the calculate when I calculate the cooling rate, the average cooling rate in the experiment A and experiment 2 is تقريبا is the same يعني difference between them is smaller. So the answer is correct فعلا لانه الانسر is قريبه جدا من بعض ولانه الديفرنس بينهم تقريبا 70% and 70% is smaller than 10%, which is within the limit of experimental accuracy. Okay, here the last question in this question number 2, state two variables which must be controlled so that the comparison of x1 and x2 is valid. x1 and x2 is valid. يعني أنا عايزة أشوف مين هم control variable. Okay, a lot of students can make this mistake. Be careful, please, because let's go back again for the beginning of the question. Okay, the highlighted purple here. The student investigate the cooling of hot water from different initial temperature. So we need to make a relation between what يا جماعة? Between how can the initial temperature, which is the independent variable, the variable I will change. Okay, this is the independent variable here. The initial temperature, I will change the initial temperature in both experiments, okay? And how the initial temperature difference or effect in the rate of cooling, the rate of cooling. So be careful. You cannot make the initial temperature لان معظم الاكسبيرمنت احنا كنا بنتعود كولينج اوكي احنا بنغير كل الفاريبلز ولكن بنكيب the temperature is the same, the initial temperature is the same. No, فبي كيرفل احنا محتاجين نعمل ريليشن نشوف how the initial temperature ازاي الانيشال temperature اللي عندك affect on the rate of cooling. تمام. واحنا اساسا قلنا ان في one from the answers in this answer انا I predict and I conclude from the experiment practically اللي اتعملت من الاكسبيرمنت انه كل ما كانت الانيشال temperature greater as the rate of cooling will be greater. So you should not at the end of the question when he asks you to state the two variables which must be controlled ما تقولوش same initial temperature because this is an independent variable. ده الفاريبل اللي انا غيرته اساسا. انا ممكن اقول ان انا I measure the temperature in the same time interval and then I take the same interval I record the temperature in the same time interval ان انا استعملت نفس الفوليوم of the water for the both مثلا I place 100 cubic centimeter to 100 cubic centimeter مش في كل مرة غيرت الفوليوم ان انا استعملت نفس الليكويد ما استعملتش مرة ووتر مرة اويل مرة بيكر. الشيب اوف بيكر ما ينفعش استعمل مرة كونيكال فلاسك ومرة استعمل ميجرينج سيلندر ومرة استعمل بيكر. You should use the shape of maker the same. The surface area يعني you cannot use a wider surface area wider beaker and narrow beaker. You can use the same room temperature the same condition the same environmental condition ما ينفعش اقول له same condition واسكت same appropriate environmental condition. for example ما ينفعش احطها في مكان مره تكون windy ومره تكون مثلا عندها viscous environment او يكون فيها water vapor تكون كبيره او يعني تكون يكون نسبة الووتر فيبر فيها كبيرة. Thank you for watching and we will complete question number 3 in the next video. Thank you.